Okay, so f of g of, let's go through these. F of g of 25,
Okay.
3. Does that
So,
real world mean?
where do I want to start?
Okay, because, and the reason is because what's the output of g? Okay, but what does it represent? The output of g.
Okay, so last time
Depth of the beam, and that's also in that expression representing
we
what?
ended by talking about these.
This function that, given
Yeah,
the
that's right.
Celsius of
So
input,
I'll write it down here.
it
So
outputted the Fahrenheit, and that was the g function. And then what we did was we created the inverse function. Okay, we created the inverse function, which does the reverse process or undoes that process. So the input now in this one is Fahrenheit,
f
and it
of
spits out the
g
Celsius temperature.
So
What is it,
we
25?
use these symbols C and F to represent.
So this right here
Celsius and
takes on
Fahrenheit.
2 roles. This is the
But
whole
what
idea
I want
of
to show
this
you is
process.
that generically, what's normally
Putting
done
values through a 2-step process. G of 25 has
is,
2 roles.
X
First,
is kind of the
relative to
generic
G, it's
name
what?
for the input of any function. Okay.
Input or output. So what? And so if X is the input of G, what does
Input or
X
output,
represent
G of
here?
25. What does X mean?
No, G of 25.
And
relative
what is
to
the input?
G.
What is the quantity?
It's an input or output.
Celsius temperature, right? Celsius
Output.
temperature. So we could
Relative
write
to
G of X
G,
equals
remember? That's our
9/5. And
the
so what do we
output
do to Celsius temperature to
of
get Fahrenheit? First
the function
we
G when the input's 25. So relative to G,
multiply by 9/5.
it's output.
The input
Relative
by
to
9/5
F.
and then add 32,
What is
right?
that thing? Input
Okay.
of F.
And so then
So in order for this to make sense, the
what's
quantity
commonly
of the
done is
output
we'll
of
use
G
X
has to be the
again
same
in
quantity
the
as
inverse
input of F,
function.
or
So we'll
else
use X
F
again.
will say to mean the
No,
input,
I don't accept
but
that
now
because it's
this
not my
X
function. It
takes
takes on a
not my
different meaning.
function.
What does
It
X mean in this
something
context?
else other than, what does it take?
F takes, this is the Fahrenheit temperature,
Required
right?
depth, right? So in the context of G
This is the
in
depth of the
the
beam.
inverse function, so therefore the output of G
That
better
will
be the
mean
depth of the
Fahrenheit,
beam,
whereas
whereas
this
X
won't
over
work.
here means Celsius.
You see?
So this is
What
very
is
common
Is
practice.
it the depth? Where X is
Yeah.
just always your
So what
generic,
is the depth of the beam at 25?
your generic symbol for input.
But
told me 12.
in the
And so now 12 is the
function and
output
its
of
inverse
G,
will take on a
but it's
different
also
meaning.
the
Take on
input
a
of F
different
now.
meaning.
Okay? So now we can say it's the same thing as F of 12. So don't let that confuse you. 49.96. And what does that number
this is
mean?
a very
common way to do
Cost
this.
of.
Okay? Questions about that? Cost per foot of the beam if. All right, so let's do an
Good.
overview.
If the maximum
of
span is
inverse here.
25, right? So we started with a maximum span of 25. We go through this 2-step process. The middleman is what beam depth.
Okay,
is
so the first thing I want
middleman.
to say is we
And
talked
we
so
get
this
the cost
this
of the beam,
notation
whose
max span is 25.
It's like an exponent.
All right, what about
negative
G
1.
of F?
It represents the inverse of F of
Does
X.
it work?
Okay. That notation
doesn't work
does not
because
mean 1 over F of X. So you maybe
The output
it's
of
not
F
an exponent.
is
per
not
se,
the same
right?
quantity
It's
as
not
the input of G, right?
Take
The output
1 over
of
the
F
function.
is a different quantity. So
Right?
G says,
What does it mean?
no,
It
I don't
means
accept
reverse
that.
process or undo
The only thing I
process.
take is maximum
Okay, so
span,
be
and you're trying to give
careful
me
for
something different. So it
You don't
rejects
take-
it.
To get
It
the
doesn't make
inverse function,
sense.
You just don't take the function and take 1 over it.
Okay.
That's not what inverse is.
How about this table problem? Any questions
All
about
right,
the beam?
just that's kind of
Perspectives and properties.
again from Friday.
So
stuff.
there's two kind of main
What
perspectives
about the beam? So G
about
of F
inverse
of
function.
negative
One of them is
Where
that
is
the inverse is the
Joshua,
reverse
Recky.
process of the original function.
Where's Joshua?
Okay, reverse process of the original function. So we have a function. Yeah. All right.
It's
How
like
about
that
that
first
first
one,
one
right?
for
So
the
it
table?
takes input, it cranks on the input, and gives us output. So what
How?
if we think of this as the reverse
Process. What are we thinking about? Well, it's the same machine, but instead we run it how? Run it backwards. Okay. So that would mean
Yeah, so
that
what do you see?
where
You're
would
looking
your
at the
input
negative
be?
one first?
Your
So
input
then
is
we
there,
wanna
and
know what
it's like
f
we're
of negative
cranking the
one is,
machine
right?
backwards. We're reversing it,
Which
and
is?
your output's there. Okay, so if that's the case, then what? The output of f of
Help from
x
Jacoby.
is the same
Jacoby, you wanna
quantity
take
as
over?
the input of the inverse. You see that? So, and then similarly, the output of f
Right, so
inverse
this
is the
G3
same
is the
quantity as
output of
the
F,
input
but
of
it's
F.
also what?
So the input and output switch. When you reverse
Input of
the
G.
process, input and output
You
switch.
see? So that's 3. And then that G of 3 is?
Okay, so in our
Here.
notation, what I want you to do, here's the notation f of x. I want you to identify
Okay.
4 different things
Someone help me with...
as they appear in this notation. Identify the input
Let's do, how about,
and
let's try this one.
output of
G
each
of
function,
G
the
of 0.
function
Where
and its
is-
inverse. So
Matthew Hale.
as it appears in this notation,
Tell me.
can you identify the input and output of both the inverse, both the original function and the inverse? See if you can do it.
Okay.
So where does, say, the output of the original function appear?
where does the output of the inverse function
So that thing
appear?
I put a
Where does
box
the
around right there,
input
what
of
is
the
that?
original function appear? Does that make sense?
You got four things to work on.
Okay, and what's the value?
Talk with
2.
the person
So
next
the
to you.
output of G when the input 0 is 2. But now that 2 is also the input of G again, right? It's the input of G again. So we go to here, -1. So one thing, you guys are all engineers, right? So in
These are the
creating
four
this course,
things.
one thing that the engineering, the administration, and faculty said was, we just want a course where they understand this. This was one thing they pointed out, that students are coming to us in these engineering courses, they don't get the idea.
All of them, all
a
four things are
two-step
represented
process of
somewhere in that notation. So
Okay.
we're
How is it?
figuring
Does it
that
make
out.
sense?
So
This is called
where is
composition.
Ralph? You're up.
Of
You
functions.
get to pick. You're the first one, so you're lucky. So which of the four do you want to
I
tell
said
me?
we're getting these engineering students in
What it is.
our higher level classes, and they don't get this.
You can pick any of the four.
Get this
Tell me
idea
how
how
it
it appears in this
The
notation.
input goes into a function, you
How
take
it
the
represents
output and you
any
put
of
it into
those
another
four in
function.
this notation. And that's how we represent it.
Okay?
That's how we represent it.
It'd be what?
Okay, so let's go back to that example.
So where do you
last
see the
time.
input of
Any
F here?
questions on these table problems?
What's that?
Okay, let's go back to this
The X.
example.
That's it.
And so what
So
do we
this
do?
right here?
So
It's the input of F. Hopefully we all got
Number of
that.
workers per day.
All right,
Gives us
so
an average.
Hopefully that's the
shift,
easiest one.
And
Okay, next.
then we come over here, take the average
Where
length
is-
per shift, and then get
Nasser.
the number of expected accidents.
right, so is that F of
Nasser?
G
Nasser?
or G of F? Which is that?
Khan.
We're doing
F
F of
Tell me
G,
anyone you want. You got 3 left.
G of F. If we start here, and get this output.
The output
also
of which
the
one?
input of
F or F inverse?
And get
F.
that output.
So
Is
you're
that
saying the
F of
whole
G or
thing
G of F. Yeah.
represents?
she wants F of G.
Output
Agree with
of?
that? Yeah, that's
F.
what it is, F of G.
Agree?
So, but that's kind of cumbersome, right? So if I wanted to
All right.
say I've got all these different number of
You took the
workers
easy ones.
employed each day,
There is Arturo.
and I just want to know how many expected accidents.
You're up again.
It's kind of cumbersome to have
I
to
think I
do
called
this
you
two-step
yesterday.
thing every time.
Monday.
So
All
what
right,
we
so
did-
now you got to do either the input or the output of F inverse. Can you tell me
What's
one
that?
of those?
Make a new function. What would the input of the new function be?
Right. It's the same. It's also the output of F, right? So this whole thing again.
Alec, number of workers each day. Okay? And what would the output of this new function be if we're trying to streamline the process?
So the input of F inverse is
he wants
the
number
whole
of
thing.
industrial accidents. Agree? Yeah.
okay. So what about the output
Okay.
of F inverse?
So we could create a new function that just takes out the middleman. What's
Yes,
the
sir.
middleman?
Evan.
Average length of a shift.
just X.
and just gives us the number of
So that
expected
is
accidents
the output of F inverse.
given
The number of workers employed each day. Okay.
This is
so
really important when
I
you
know
start
you
to
could
get
all
into a
make that
problem.
table, so just
and
do
you
it.
have these quantities flying around and they're asking
Okay.
questions
So
about
there's
different
this table.
processes. You gotta have
So
this down, right? That's why we're taking the
it
time.
takes you
really
directly
gotta
from
be
this
confident
value
to the
what the different
corresponding
symbols
number of
represent in the
accidents.
context of
So
F.
that's a new
and in the
function,
context
okay?
of F inverse.
That streamline
Questions on
process is also called the composition. So there's two ways to look
Okay,
at
do
composition
it again.
of functions.
Same thing. Go.
Thinking of it as a two-step process that we've done so far.
So
Or
four
creating a
things:
new function
input and output of
that
F,
just does it
input and
all in
output
one.
of F inverse. How are
Okay,
they?
so
how are they
both of those
represented?
are
or how do they appear in this?
composition.
So working with both tables would be composition as a two-step process. Working with just the new function h
Would be composition as a one-step process. Does it make sense? Anybody have a question? Okay. So we're going to go to, in your book, you're going to flip back to, yeah, please, thank you.
Now, did you put all that one by one into the...
Where's Riley?
Right, I had to go through and do it. I had to say,
You
okay,
get
if
to
there's
do two, it's
60,
your lucky
it's
day.
13, 13, 18. So I put
Which
18
two do you
in.
want to do? Tell me. Any two you want.
No, there's no formula. There's just tables. I use the table to build the new table. But we're
Nice
about
and
to
loud.
do formulas.
We're about to do formulas, yeah.
Input of F inverse.
Okay, so I want you to go to,
Okay.
in
But
your
F of
book,
X isn't here. We got this is the notation we got for F inverse. So where do we see the input of
page
F inverse? there?
92. So flip back a page and look at number 2.
So this is F inverse. So where's the input? X. So that's the input of
Okay, so a pebble is thrown into a lake.
F
The
inverse.
radius travels outward
at the radius of
Okay,
the ripple
wanna do another
travels
one?
outward at 0.7 meters per second. Our goal is to determine the area inside the ripple for a number of seconds elapsed since the pebble
The
hit
output
the
of
water.
which?
For determining a function. Okay, so
That's
we're
it.
going to skip. So that's the setup.
We're going to skip right to question
All right, and then
D. Okay,
Good
so
job.
based on this setup,
there is
go to D
Abdulaziz.
on the top page 93, and you want to write two functions.
Can you do the other two?
F.
Where do you see the input of f here?
It defines
Which
the radius
where
of
is
the ripple
the input
as
of
a
f
function
represented?
of time, and the function G that defines the area of the ripple as a function of radius.
The whole thing
So you're
Yeah,
working on
the whole
D
thing
at the top of page
is
93.
the input
The
of f.
setup on the previous page.
And so where do you see the output of f? X. Anybody have a question? Okay, so on page, you got something like this in your book.
I think. I hope. Oh, maybe not. In your book. Oh, number 4 on page 103? Yes. Number 4 on page 103. So here's an example where you really need to identify what you see as input or output of the correct function in order to solve this. Okay? So page 103, number 4.
Page 103, number 4.
Okay, get a partner, share what you did, compare what you're thinking.
Okay, Rayan. Yusuf. Vader. Jose. Ali. Abdullah. Hamed. Jacoby, yes. Matthew Armis. Ajane. Byron. Riley is here. Maria. Arturo. Mickey. Abdulaziz. Janet. Evan. Patty. Miles. Miles here? Yeah. Jennifer. Matthew Gilbert. Joshua Grecki. Matthew Hale. Rachel. Derek Harrington.
Where's Taz?
Brandon.
Taz.
Humphreys. Carlo.
How'd it go?
Where's Carlo?
How did function F go?
Jack. Peter J.
What's that?
No Peter J?
Yep.
Morgan.
You said F of what?
Kyle Johnson. Nicholas. Kilpatrick. Alec Kindle.
So first of all,
Mitchell.
what is the? We know that F is the
Nyara.
name. What's the input into
Ryan Lanise. Angelina.
R or T. If it's R is a function of T.
Emily.
T. So
Ginger.
what does F of T represent?
Alyssa.
That notation right there, F of T.
Sonia.
It represents a radius. What
Who's
radius?
Sonia? Okay. Danny.
The radius at
Hayden. McIver.
time T, right?
Travis.
This represents the radius
Luis.
of the ripple at
Luis.
T seconds since the pebble hit.
Isaac.
That's what that represents.
Okay.
Horatio.
So we need the rule.
Julie Parker.
What is the rule? The rule is
The formula
Jackie.
that usually has
Colin.
T's in it, it may not, but
It's
usually
Colin.
has T's in it that will give us R for
Renee.
a given T.
so. What is our rule?
Joseph Reeby. Kyle
0.7 T. How'd you get that?
Zachary Roy.
What's that?
Ruby. Alex Sanchez.
Good. It's
Jordan.
the constant rate of change, and so
Taz. Taz here?
every second that goes by, the
Cat.
radius will increase
Hayden
0.7. So if it was after 0 seconds,
Jeffrey Smith.
0. After 1 second,
James D. Vader.
the radius is. After 2
Jessica
seconds,
Stratford.
1.4, etc. So if you're not
This
sure
is
how to make a rule,
Charles.
make a table. It's really helpful.
Is this
Make
Charles
a
here?
table of corresponding
Next time.
values, and then the rule starts to pop out at you.
Jack Trumbull.
You're not sure.
Here. That's here. Cesar. Brenda.
Okay, so I just want to point
Vargas.
something out, just to remind you. This
Chandler.
is called function notation.
Joseph Wall.
This whole thing is the
Jacob
function
Wall.
definition. Okay,
Stephen
so when
Wicker.
you have the output
Steven.
equals the rule, that whole
Marcus
thing we
William.
call the function definition.
Chung Yang.
Whenever we say function notation,
Yes.
we're just saying we're representing output, like here, like the left side of the equation. Okay.
So the whole thing is the definition. The left side is function notation.
Okay. A is a function of R. Where is Stephen Wicker?
Okay, I'll just take requests. We're not going to go through the whole thing.
Where's Stephen?
Requests on these. E. Okay, so 6. What does
A
6
is a function
represent?
of
It
R.
actually represents
The
two
name
different
is G,
things.
so what's
What does
the
the number
input?
6 represent in this problem? It represents an input. Input of what?
So if we say A as a function of R,
The input of F inverse.
Is A the
do we,
output or
do
the
we
input?
have F inverse in here? No, we have the function F. So what is it relative to F?
that's the output,
of
therefore
F.
R is
So
the
we're going to go
input.
to F and look at the output values and look for
So now
an
we need
output
a
of F of
rule that if
6.
we had the radius of a circle,
What does this
would
whole
give
thing
us
represent then?
the area.
Input, output
So
of
what
F
rule,
or F
given the
inverse?
radius of a circle, would give us the area?
Oh, forget about G for now. Just
What's
in
that?
terms of F, is it the
Travis
input
is
or
taking
output?
over. Sorry, Stephen.
No, it's the
Pi r
input
squared,
of
right?
F,
That's the rule that takes the radius of a circle and gives you area of a circle.
corresponding to an output of F of 6. So that's why we practiced that previous slide. It gets confusing, okay? So
Okay.
that's the input of F
So-
when the output of F is 6. So what number
Let's
is it?
look at these two. And what was our goal?
2.
We wanted to.
Okay.
It says.
But now
we wanted
2
to determine
also
the area
is looking
for the number
at
of
G
seconds
inverse.
elapsed.
Go with red.
Okay. So we want.
So now we have
Area.
basically we have G inverse of 2. So relative to the
So
function
given the number
G,
of seconds elapsed,
what is 2?
we
The
want
input or the
area.
output of G?
So talk to the person next to you.
Output
How
of
are we
G.
going to do that? Go.
Right?
So
It's
We got these two
switched, right?
functions
It's
now.
switched. This is the
Given
output of G,
time,
so we're
we
going to
want
look at the
area
output of G of 2.
Within the ripple.
And the whole thing
What are you
is
going to do?
the input of G that would give an output of G of 2. So this gets confusing. That's why we took the time to work on this input-output stuff. Because you really got to practice. You're so used to this being input, right? But if in the inverse function, that's the output of the original function. And the whole thing is the input of the original function. Okay. Does it help? Is that Matthew? Did you express that? Does that help? Okay. So I think we're gonna move on. Did these go pretty good? Anyone just want an answer? So any just answer request. What was the answer to F? People are saying 1. And someone said -2. I'll do it fast. So G of 2. 2 is the input into G. Output of G is -1. But now that's the output of F, -1. So the input, the whole thing is the input of F that would give an output of -1. So I think it's 1. Okay, last chance for questions on this.
Okay.
So how are we going to get area given time? How are we going to get area given time? Where is Arturo? Okay, so the
How are
other
we gonna get area
perspective
given time?
on inverse functions, so we talked about it's the reverse process. If it's the
Nice
reverse
smile.
process, then the input and the output get switched.
What are you
The
going to plug
input
in
of the
first?
one function is the output of the other, and vice
Into?
versa. Another way to think of inverse is that F
Okay.
inverse
He
undoes
wants to
the
put time
process
into the
of
first
F.
function.
Okay.
And then what?
So they're similar but slightly different. Okay, this reverse versus undoes. So how would we symbolize undoes? So we got F, and we're going to put X in, and what's going to come out? How
You'll
can
get
we
radius. That's right.
represent
So
what's
you're going to
gonna
plug
come out
time
of
into the
this
first function, and then you'll get radius. And then
F
what?
of X is the output, right?
Plug into the second
Okay. So now
So now
if we
this,
put F
this
of X
output radius
into the inverse,
becomes the input of this one.
if it undoes
Is
what
that a-
this one
is that a
did,
working
what's going to come out of that notation? Does that work? So smart. Because the
Okay.
output of F is right. So what I want you to do is
The input of
use
G is-
function notation to represent this whole picture. The
R.
whole picture. Can you use function notation
to represent the whole picture. See if you can do it.
Okay, so right, the output of F has to match the input of G, which in this case it
And
does.
you
They're
write
both
function
radius,
notation,
so
right?
it works.
Function notation is something
Okay,
like this, right?
so now we have
H
this is the
of-
first time we've had actually a
just an
rule.
example, it has
So
nothing to do
what
with this
is
one.
F of T? It's the
You know,
same as
H
its rule.
of
What is its
A
rule?
plus 100.
0.7T.
That's function notation,
right?
right? That's function notation. So can you write function notation?
So given the rule of G,
represent this
what
whole
does
thing,
G
that whole
of
picture.
0.07T mean? Given the rule of G.
Talk to the person next to you. See if
This
you
is
agree.
our input. And this rule says take the input and square it and multiply it by pi. Yeah, tell me. Yeah, so this rule says take pi times the input squared. So we're going to take pi times the input squared. Okay, and we can simplify that and we get not enough room. Pi 0.49 0.49 pi t squared. Okay, so we have this new rule. What does this new rule do? It takes
Okay, Jordan,
our inputs.
how'd it go? Any luck?
Time and outputs.
Tell me what you thought.
What does it output? Area, right? So we just created a new function, a one
X is the
rule
input.
or a new function.
That does the two-step process in one step, right? So it streamlines this idea of
But we want to
Every time
write
you
this
add-
in function
getting the radius,
notation,
putting the radius into G and getting the
meaning
area.
an expression
This-
like,
This
you know,
rule
H
is
of,
new
like I
function
said,
that
A
does
plus
it all in
100.
one step.
So can
You
we
put the
use
time
a
in, it just spits
function
out the area,
notation to represent it?
takes away the middleman of radius.
Okay? Who's next to him? In the blue
So
shirt.
that's the idea of composition.
No
Either
idea.
a two-step process.
Keep going down the line.
Output
Couldn't do it,
becomes input
okay?
of the next function, or you can create a new
Rachel.
function like we did with the new table previous that does it all in one step.
Okay, so where does
All right, so
what's
let's look at
first?
that.
What happens
We got
first?
A nice visual of this here.
That's right. Does F happen first or F inverse? F, right? So we put X into F and we get F. And then what happens?
Here we go. All right, so think of the machines.
We're going to take that and do what?
What function was first? Which
Put it into
function
F
was
inverse. You see? And that
F or
will
G?
give,
F, and F took
really
what?
important,
Takes time and gives
really important, okay?
radius.
First, we put X
And then
into F, and we got
next,
its output. Then we
G
took
takes that
radius and we put it in F inverse. So this is
and
a
a
result
visual
of
of
X.
composition
So
as a
That's
two-step.
really important that you understand that. Okay, and there's the rule,
Okay,
right? So there's the rule
questions?
that gets radius from time,
So,
and then area from
if-
radius. F inverse undoes
And
F.
then what we did a little bit of math, and what we
started
made
with,
one-
what undoes F inverse.
turned it
What
into one
undoes
time
F inverse.
machine.
That does it in one step.
Watch this. Ready? Took me about 15 minutes.
Okay, so if F inverse undoes F, then F
Okay,
also
any questions on
undoes F inverse. Okay?
Do it.
Use function notation to represent that. So how would you do function notation? This should be easy now. How would you use function notation to illustrate that?
Okay,
So now when you don't have a context around your functions, here are just some functions that are given. We don't know what quantities the input and output represents. So in a situation like this, it's possible to reverse it. Like we could talk about f of g and also talk about g of f, because there's no quantities assigned to the
Where's
input and
Todd's?
output. Does that make sense? All right.
How'd you do?
So evaluate g f of g of 2.
all right, so what does that say to do? First, you put 2 into,
F of
G?
F of inverse of
is
equals.
it Jennifer? Keep going. Then what do you do?
What comes first? F inverse comes first.
What is G of 2? Can you figure that
X
out?
into F inverse, and we get the output
13.
of F inverse.
G of
And
2
we
is
put that
13, and
output
then?
into F. It undoes what
That
F
into
inverse
F, and
did,
you get?
and it gives you back the original, what you got
Oh.
originally.
That was fast. Good. Square root of 13 plus 3.
Okay. Any
is 4.
questions on that? So
So
In terms
the way
of
we
if
just
you-
talked
if
through
you
it was
start
the
with a
two-step
function and you
method.
want to find its
So
inverse
can you
function,
create a new function?
we want to think
that
about
does
it
all
this
at
way.
once.
So
Go.
let me
See if
show
can
you.
create the new one
Let's go
function
back to our
that
example.
does it in one step.
This one.
Okay. So the way we talked through it, first we got 13, then we took 13 and plugged it in here and got out the answer 4.
So what
can you
was
create
our
one function that
original
does it all
function
in one
G?
step?
Here? G was 5/9 x plus 32. Is that right? Do I have it wrong? 9/5? I just guessed. Is it right now? Okay, so we'll make this machine here. And make it plenty big. So we're gonna put x in, and now we're gonna like actually break down the guts of this thing. Okay, what happens first so this is the G machine. So you're gonna put x in. What happens first to the input? First what? So what does this say to do to the input first? 9/5 of it. 9/5 times the input. And then what do you do to that next? You add 32 to that. Not just to the input, add 32 to that. That whole thing.
So what you would do
And then
your G of
we
X
get out
is
the output,
is
G of
the same
X.
as that rule, 2x plus 9. So you can substitute in.
Okay,
2x
so
plus
looking
9
at those
G.
steps, if
Now
we want
2x
to build
plus 9 becomes
the
input
the
into
G
F.
inverse machine,
And what does F say to do to the input?
okay, so this is G inverse.
First
Then-
do what?
So now,
You
the
square root
input
first,
into
is
G
that what you
inverse,
do?
we're also going to call
Or
x.
you
That's
add
what I was
3
talking about at
first,
the beginning
right?
of
So you
class.
take
We're
the
also going to
input,
call it x, but it has
there's
a
the
different
input,
meaning now, right?
And you
So if this
add
undoes
3.
what this did, if it
And then what do you
undoes
do?
it, then what will be first?
square root it. Okay, so we could.
You're going to
that
subtract
is the square
32, so
root
it's going
of
to undo
2x
it. So it's
plus-
like going backwards to the machine. So the first
Well.
thing you're going to do is you're going to
So
subtract
what do we
32.
do? We just created a one-step process. You could call it like H or something. Or
And
P.
then what's the next thing you're
No,
going
they
to do?
already use P, so we'll call it Q. So Q of X,
Divide. You can say
It's a
divide by
one-step
9/5 or
function definition
multiply by 5/9.
that has
The same function.
We'll
as
say divide. I like
putting it
divide
over
by
the G,
9/5 because it's
taking
truly.
that output and putting it into F and getting a
So
final
you're going to
output.
divide this whole thing.
This-
Divide by 9/5.
Square root of quantity 2x plus 12 does it
And
all
you're
in
going
one
to get
step.
G inverse. So now that we've got these instructions, now we can write the function. So G
Yeah.
inverse
Thank you.
of x. What do you do first? Subtract 32.
Yeah, you can
then what do you do?
3, so you could
We could
Divide
do
by 9/5.
G of F of H.
So by thinking about the process, the set of instructions that the original function does,
Okay.
and coming
Good
up
practice.
with
Let's
the
do it. So
reverse
do-
set of instructions.
what does
it's
this
like
mean?
going backwards
What
with the
process
machine,
comes
how you
first?
want to do it. It can help you to
H would
find,
come first.
given a
We
function,
would take the
find
output of
the
H and put it into F,
Okay, so
and
let's
the output
practice
of that output into G.
that. Any questions? Does that make sense?
So
Let's
what
get
is
some good
H?
examples here. So this one,
X over 4.
this one.
And what is
Okay,
F of
so we'll
X
just
over 4?
we'll change it to f of x. So this is gives the volume of a sphere.
So again, X over 4
so
is the
just
input
change
into
the r to
F.
x.
What does F say to do to the input? Add 3 and take the square root, right? And so that becomes the
So what I want you to do is
output
First-
of F, right?
write out
So now G,
out
now here's your,
the-
but it's also your
the
input
set
of G.
instructions
And
that
what does
it-
G say to
that
do
it
with the
does
input?
on the input. Then write out the reverse set of instructions, and then use the
You're gonna
reverse
take
set
the
of
input and
instructions
do
to
what
write
first?
out the formula, the rule for F
Multiply by
inverse.
2.
So first write out
And then?
the set of instructions
Add
that
nine.
f does.
I didn't rewrite it, okay?
Ignore these questions.
So this is the
Yeah, no,
one
I'm
step.
changing it. Ignore these. All right, so you're gonna write out first.
So
Write
this is
out
this whole thing right here. This is the one-step rule. 2 times
set of instructions.
square root of the quantity x over 4 plus 3 and quantity plus 9 is a one-step rule that
Correct.
does this 3-step process.
Write them out, and then same thing. Write them out. Set of instructions for f inverse,
Okay, anybody have a question about that?
and then based on your set of instructions, write the rule for f inverse. Go. Okay, take a look at. Can I erase? Anybody have a question? Okay, going on to slide. It's the
50.
volume of a sphere. Execute. It's right here. Okay, so we gotta find this problem in your book. It's quite a bit ahead here. Okay, I'm gonna redo this on a different screen. Page 102. Okay, on page 102, it's talking about temperature in Fahrenheit. This is when traveling outside the United States. It's often useful to be able to convert between temperatures using Fahrenheit scale and Celsius. Okay, if you go to Canada, if you've ever been in Canada or most other places in the world, they say, oh, it's 35 Celsius out. And so, what does that mean in terms of Fahrenheit? Because we're used to Fahrenheit. Okay, so you've got this function that inputs Celsius and gives Fahrenheit. And so they're naming that G. G of C equals 9/5 C plus 32. Okay, so in part A, they do G of 100. 100 represents what? A Celsius or a Fahrenheit? That's a Celsius, right? Because the input into G is Celsius. And so the rule says to take the input, multiply it by 9/5, and then add 32. That's what the rule says. And what does the output of 212 represent? Feel like you're a pro? That was a piece of cake?
This one's a little harder. Fahrenheit
2x minus 5 all over 6. 2x minus 5 all over 6. Work on that one.
Celsius.
If you're still on the first one, that's okay. Okay, so we're going to skip down to part C. We've got that G of C equals 9/5 C plus 32. And what does the output of G represent? What is the output of G? Fahrenheit. So because it represents Fahrenheit, you could just also write it just as a formula like this without the function notation. Okay? So we want to create a new process H that takes Fahrenheit and outputs Celsius. Okay, so we need a rule that works on Fahrenheit and gives us Celsius. So what do we need to do? We've got this formula. What do we need to do to the rule, or what do we need to do to create a rule that we would input Fahrenheit into the formula and it would crank out Celsius for us? What do we do? Right, so we're going to solve for C, right? If we solve this for C, then we'd have a formula of F that would give us C. So what's the first step in solving for C? Subtract 32 would be 9/5 C. And then the last step would be divide by that or multiply by 5/9. Okay, so that's our rule. 5/9 of F minus 32 is a rule that takes Fahrenheit and gives Celsius, and so that's what we're going to name the H function. The output of H would be the Celsius. Okay, so I put the solution up to number 1. First thing it tells you to do is to cube the input. When you have a Fahrenheit for input. Then, second thing, take that result, multiply it by 4/3 pi. So if we're going to undo that, okay, so we have these two functions now. Divide by 4/3 pi. And then take that result and? How are these functions related?
Convert it. So there it is. You take the input, first divide by 4/3 pi.
So this one does what? It takes
Celsius and gives Fahrenheit.
Okay.
This one takes Fahrenheit as input and gives
pi?
Celsius.
I was just checking you.
So the word inverse.
Better?
What about those processes? How are those processes related?
Yeah, Jack.
Right.
Yeah.
So this one, if you put Celsius through this process and got
'cause it's-
Fahrenheit, what if you took
Think
that
of it as
Fahrenheit
the
and
whole
put it into
idea of
this
going
one?
backwards
What would it do?
here. What did you do first? First you cube the input,
It
and
would
then you
reverse
multiply
or
that result
undo
by
what
4/3
all the
pi.
work that you did up
So if
here.
we're going to go backwards,
So this one
what's going to happen?
undoes
First, what do we do? We're going to
H
divide by that. And then
undoes
take that whole
or-
result and cube root it.
Yeah.
So it's thinking about going how
What
would you
G
go
does.
backwards. How would you undo what you did? So yeah, you cube root the whole thing. That's important.
So if we put 35 Celsius into this, we would get some output of Fahrenheit, right? And what if we took that output of Fahrenheit and put it into this function?
Okay. Who thinks they got
What
the
would you
second
get
one?
out?
Somebody
What
knew.
Celsius temperature would you get out?
Tell me your name again.
35, because
This one
Joseph.
would undo the work that this one did.
okay. Another way to think of it is it's the reverse process.
So you think of your machine.
Multiply by 2.
Input goes in and spits out output. So that this function is like if you turn the machine backwards. It would take those values and give you.
All right. What's the next thing you do after you
Make the
multiply by
machine go
2?
the other way, right? It would reverse the process.
Subtract 5.
Okay, so
Divide by 6. So here's the. Each time you take the result of the one before. So then you
what you're
subtract
telling me
5
then
and you
is
divide
if-
by 6.
What was our? What
So
was
the
fir-
inverse is
first
going to
function,
be
G?
like what? What's first? Multiply by 6. Then
G of C.
Add
If we
5
put a
to
Celsius temperature
that result,
into that
and
function
then
and got Fahrenheit, and
divide
then took
that whole thing by
Fahrenheit,
2.
put it into H.
So we're going to first take the input and do what?
What should happen?
Multiply by 6.
You're going to get whatever
Then?
your original Celsius
Then
was.
add 5.
G is going to do
Divide
some
the whole
work to
thing by
make
2.
Fahrenheit. H is going to
Undo that work to give Celsius. So let's
That's
prove it
the
mathematically.
process that
What is
undoes this
G
one.
of C?
So don't look for tricks.
So what is
go
G of
through the
C?
process
Where
every
is-
time. Don't look for tricks and just
Try to write them without
MacGyver.
thinking through these two middle steps.
okay. Write out the process of the original function.
The undoing
No,
process of the inverse and the final result. Any questions?
Where is Joseph Reeby?
Okay, so let's look at this this sheet.
So yeah, so that's our G function
I'm
is
defining
the
F
rule 9
as the number
fifths
of
C
people
plus
expected at a
32.
local concert if the temperature is X degrees.
And we need
F
to write down
for
our, so we
Fahrenheit.
got G of
And then G
C
is the total revenue.
is 9 fifths C
hundreds
plus
of dollars at the
32, and what
concert
was our
if the
H of F
attendance
function?
if the attendance is X number of people. Again, see here's this use of X as a generic input, but with different meanings
Quantity
depending on the
F minus
the
32.
context of the function you're in.
Okay, so now everyone
Okay,
do the next
so you gotta
step.
go through
So
these
this is saying
expressions.
H of this expression
so you might
right
start
here.
by
So what does that equal?
identifying
Everyone do
input
it.
and output of F
H
and
of
F
that
inverse.
expression right there. What does that
Identify the
equal?
input and output of G and G
We all
inverse
should be able to do
being
this,
in terms
but I
of
have
the
a
quantities,
feeling
real world
many will
quantities that they represent.
Stuck on this.
Before you start. And then
What
you're
does
going to go
H
through
of
these.
this
Some of these make
input
sense. Some
need
of them
to
don't
do?
make
Or
sense.
what does it
we
equal?
said if you
Go.
try to put. So what's the input into F? What's the quantity of input into F? Show me your
Quantity.
answer. I want to see. The number of people or temperature? Temperature. So if you try to put anything other than temperature into F, it's going to reject it. If you try to put volume into F, or profit into F, or height, it's going to reject it. The function of F is to take temperature and give you number of people expected at the concert. Okay? So that's what you're looking for, ones that work and ones that don't. Okay, again, you might start by identifying those quantities that are the input and output of F, input and output of G, input and output of F inverse, input and output of G inverse, and then see if you can figure them out, okay? This is really good practice to see if you understand inverse and composition. Go. Some of them work, some of them don't. So for the ones that work, you're explaining the full meaning, right? If for the ones that work, explain the meaning. For the ones that don't, explain why not. Okay? Great practice. Okay, so we've got an input for H. And what does the function H say to do? Take the input and do what? First, so here's the input. It says first, do what? Subtract 32. This is, you don't have to copy this
Take
all
the
down.
input,
It's all
and you subtract
posted
32.
in the exam one.
And then what do you do?
Okay, this is posted.
take that whole thing, and you multiply by 5/9. You see?
What's that? You don't.
Okay.
You were just saying.
So now we
is
can
it a
simplify
valid
this.
expression,
Inside the
and what does it
parentheses
represent?
first.
I'm not gonna
What's
use
9
rules.
fifths C plus
You're
32
right. You
minus
can't solve it.
32?
You can't get if that.
Yeah, you're just
really
left in there, so you get
exists, know
5
what the number
ninths,
is.
and then everything
But
inside
you
the brackets
You know what it
is
represents
9 fifths C.
like a statement that says this is the whatever. This is the profit.
Which equals?
If
That's what we thought, right? That's what we said.
So that's showing it mathematically that it's true. That H undoes what G does, gives you back the original. Okay? So therefore, talk it over.
And then
for
if
as
also-
many as you can.
Just one second. If also G of H of F returns what? F, if you have that conditions true and what we showed,
then G and H are inverse functions of one another. Inverse functions of one another. Okay, you got written homework due Wednesday in lecture, and then our exam is Thursday. I'll post a review outline today for the exam. Okay? Written homework due in lecture Wednesday. Yeah, it was that.
Sorry.
Oh, it's okay.
They changed university to being one.
So the challenging ones are at the bottom. So you do one or two of those. F through J. F through J is where it gets challenging. Okay, we'll motor through as many as we can. A, valid or not? No, because the output of G is revenue, and the input of F is temperature. F says, nope, I don't take revenue, and it rejects it, no meaning. Okay, this one. Does it make sense? Okay, so how would you describe what X is in this equation? What is X? What does it mean? Tell me. X is the attendance? So X is the input of F, right? So what's the input of F? So it's a temperature. What temperature is X? What specific temperature is X? What's that? But how can we specify what temperature we're talking about in this? It's the temperature what? What's that? But we can say more than just it's a temperature. Yeah. It's the temperature at the concert, that's right. Alec. He says the temperature will give some expected attendance that will result in revenue of $100. So what is that, $10,000? Okay, so this is the temperature that you would expect a revenue then of $10,000. So that's what you want. So what about F inverse of 70? What does it represent? Is it a number of people or a temperature? Is this the input or output of F? It's an input of F. Input is the whole thing. It's the input of F. So it's a temperature. Which temperature is it? Temperature corresponding to? 70 people at the concert. Okay, definitely. So like I said, I posted this. Definitely work through these harder ones. Make sure you understand it and can do them. Okay, don't forget, test tomorrow. Study hard. Don't forget web work also. Friday morning web work.